Silver nitrate.
Oh, I thought it was going to be blue.
Look.
Ah!
You missed it.
I was watching.
So silver nitrate and sodium hydroxide, and you saw what? Chemical change.
Colour change.
Colour change permanently. It's not going backwards or something.
This doesn't go on.
Okay, so what was that? That was silver nitrate?
This is silver nitrate.
Yep. So now we're going to add what?
Barium nitrate.
Barium nitrate.
Oh, turn purple.
Oh, that's so awkward.
Okay, girls, are you seeing any changes happening?
Negative.
No. All the things joined
So
together.
no gas?
No.
No colour?
Nope.
No heat change? Well, we can't really see any heat, but what about, do we see any precipitate formed?
No.
Okay, no change at all.
No.
Barium nitrate. There's the hydroxide. There's the barium nitrate.
Ooh. Oh, it's precipitate.
Precipitation. Where are we right? So which row is this on the table? We did?
Or is that row 5?
For the hydroxides, all everything except for barium and its group there are actually insoluble, but since we have barium nitrate, it should have been soluble, so that wouldn't have worked. So the nitrates on this table here, nitrates on this table here, all nitrates are supposed to be soluble. So it needs to be one of those exceptions to this table. So what's this one?
Yeah. Barium nitrate.
Barium nitrate's been added, and we're mixing that with
Copper sulfate.
copper sulfate,
Copper sulfate.
the blue one.
How many do I do?
Just add a couple of drops onto that. Copper sulfate.
Ooh, colour change.
What happened?
Colour change. Milky colour.
It's going a milky color.
That was a big one.
What's that called?
Colour change.
Precipitate.
Precipitate, exactly. Was our prediction correct?
And this one has particles in it.
Yeah. Was our prediction correct?
Yes.
So round number 5, barium nitrate plus copper sulfate would precipitate. Copper sulfate.
Sodium hydroxide is
Can I do
Na,
one?
right?
Because you did the last one.
Yeah.
No, I like to unspin it. It's more professional. It's blue.
Copper sulfate. And she's going to add sodium hydroxide in a few seconds. Can you see any changes?
Yeah.
No. It looks kind of like oily, like blue and oily.
Okay.
Very teeny blue bits.
Can you see any precipitate being formed though? No. Still looks pretty clear. So copper sulfate plus sodium hydroxide. Failed, did we?
No, but it might be the other combination.
Okay, on the board we predicted that the precipitate would be formed.
And they
And just
did.
double checking it now on a dark surface, we can see tiny speckles of blue particles. That's a solid, that's the definition of a precipitate. Observations for the first one with silver nitrate and sodium hydroxide. What did it look like before you mixed them?
They were both clear.
What happened when you mixed them together? What did you see?
They went brown.
Brown?
Oh, they had like solid parts in it.
Solid bits in it, yeah? Okay, the next one. Silver nitrates and barium nitrates. We predicted that it would precipitate. What did you see beforehand? Clear? What about afterwards? Next row, third row. We got silver nitrate mixed with copper sulfate. It would have looked clear and the other one would have been blue. What did you observe when you mixed silver nitrate and copper sulfate? So I'm thinking it's going to be just the same. If you started off inside the well and you filled it with silver nitrate first, and you slowly added copper sulfate to it by drop, then it's obviously you're adding more of that blue liquid into it, so it would have appeared to become more blue. Barium nitrate plus sodium hydroxide, it was cleared beforehand and it went milky white. We got the fifth one there, barium nitrate, copper sulfate. We predicted that it would precipitate. Did we see anything? What did you see? Cloudy white? Were we correct in our predictions? We predicted precipitate on this one. We saw brown and solids, so that's 1 point for us. We predicted no, that one was right. We predicted no for this one, that was also right. This one here, we predicted that it wouldn't, but it did form precipitate. Is that what you all found as well? So that one's one of those exceptions to the rule, I would imagine. That table there doesn't work for everything, but it's pretty good for most things. Okay, the fifth experiment, we predicted it would precipitate. We saw one. Last one we predicted it would precipitate, and we saw it again. We had blue specks. If you looked really closely, if you actually got the dark part and put it underneath of your wells, you would have seen that it was actually not just blue, it was actually blue with tiny specks inside. In the data table, we had to find out what the name was of the precipitate. In our prediction, we had to make a prediction of whether any combination of these ions will actually combine in such a way that they will form precipitate that was insoluble. The way we do this is we take each of those ions and we write them as if you had like a big bag. So in this first one, which we had predicted that would form a precipitate, what I did for that example is I imagined when I add my two solutions together, I had a combination of these ions. And the next step was to figure out which combination of ions would actually form the precipitate. And the combinations possible, well, we have to work that out. We've got a positively charged silver ion and a positively charged sodium ion. Now these are both the same charge, so if they were to come into contact with each other, they will have a repelling effect. They will push each other away, so it's not possible for them to collide and react to form something new. They are going to repel each other and live as separate ions at all times. So we can't have things with the same charge combining together. So the other thing we could have is if the positive ion, the cation, is attracted to the negative anion. Silver nitrate, well, that was one of our ingredients, so that's no reaction because it'll just be the same as what we started with. Chemical reaction is defined as when something new is being formed, so we can't have that. Well, the other combination we could have had was silver hydroxide. Similarly, we could have had sodium nitrate. So if I write those combinations down here. Now, the table in the textbook says that all nitrates are soluble in water, and the textbook on hydroxide will says that if you combine it with, whoops, there's no minus there. If you combine it with silver ions, it'll actually be insoluble. So that's our precipitate. These three, we predicted that there would be no precipitate, so this column here for those answers don't really apply, because if there's no precipitate, then there's no answer. Barium nitrate reacting with copper sulfate, same trick again. I'm going to take the ions, separate them, and put them in one big list. Barium nitrate. Barium lives in group 2 of the periodic table, so it has a 2+ charge. Nitrate, if you look in your textbook, has a minus charge. Same trick again as earlier. We're going to find out what possible combinations, what possible products could we have had if this reacted at all. Well, if we add barium and nitrate again, then we'll just get our original ingredients, our original reactants. So if it's the same thing as it was before, then it's not reacting. It's just the same thing. So we got to say barium reacting with the sulfate ion. Oops, forgot a 4. We could have had barium sulfate. We could also have copper nitrate, sulfate. Barium 2+, sulfate 2-, they have a 1-to-1 combination. Nitrate and copper. Copper is 2+, but nitrate's only single minus, so I need 2 of them to balance that charge. So I'll need a big bracket, stick in my nitrate, and a small subscript 2 on the outside to indicate I need 2 of these pieces. Barium sulfate, if you look up sulfates in the table of your textbook, it'll tell you that when it's combined with barium, it'll actually be insoluble, or at least have very low solubility. Nitrates, just like before, nitrates is defined as all compounds combined with that are soluble, so that's not going to form precipitate. So we stick our answer here and put it into our table. And the last one, copper sulfate reacting with sodium hydroxide. It's a single minus. Same trick as before. Or we could also have sodium sulfate. Copper is 2+, hydroxide is 1-, so I need 2 of them to balance the positive 2 on this side. So sodium sulfate. Now sodium is a positive 1 charge, sulfate is a 2- charge, so I will need 2 lots of them to balance the 2 negatives here. So for copper, when combined with hydroxide, will actually be insoluble, or at least it will have very low solubility in the water. And we are done.